Hello, math analysis. Welcome to lesson P.2A, where we're going to be talking about absolute value and the distance formula, which oddly enough are related to each other. So let's just jump in. A few basic reminders. The Cartesian coordinate plane. You've been using this for many years now. And of course, the idea is that you've got two number lines intersecting. You've got an X number line and a Y number line, and they intersect at 0 at the origin in the middle. You know that means every point has two numbers, the first one being your x-coordinate, right or left, right if positive, left if negative. The second number being your y-coordinate, up if positive, down if negative. You also know that we number our quadrants, that this is our first quadrant, the upper right-hand side. So first quadrant, second, third, and fourth, just moving counterclockwise around our Cartesian coordinate plane. So these aren't new to you. You've seen them before. They're a thing. No big deal, but we just got to refresh our memories on that. Now, do you remember the absolute value can never, ever be negative? That is because the fact is absolute value is actually distance. Absolute value is the distance from a number back to 0 on the number line. And distances are never negative. You don't tell your friends that you live -5 miles away. That's super awkward. So absolute value, if it's positive, then it's going to be positive. If it's negative, it's still going to be positive. Ooh, there's a little typo there. And of course, if it's 0, you get 0. So absolute value of a real number is always going to be a positive or a 0. It will never, ever be negative because it's a distance. So one cool little trick then that comes about. So you know how whenever you subtract, it always matters the order you subtract in? Turns out that if you're talking about distances, the distance between 2 points is the absolute value of the difference. And because your distance is always positive, it actually doesn't matter which way you subtract. Because think about it. 5 minus 2 gives you 3. Absolute value of 3 is 3. If you do 2 minus 5, you get a -3. But if you do the absolute value, oh look, it just became positive. So here's the coolest trick ever. You should notice that if you do the absolute value of a minus b, you would get the same answer as if you flipped them and you did the absolute value of b minus a. Normally, we do not flip subtraction, but in an absolute value, we don't care. It will still work because the absolute value will take care of any negatives that pop up. With this information in mind, I would like you to try out these problems. Hit pause to try them out. Hit play when you're ready to check your work. So the first problem, absolute value of -4, it probably wasn't bad at all. It was probably pretty nice, right? Absolute value of -4, it's 4. But the absolute value of this guy might have been a little trickier because 3.14 minus 6 gives me a negative. Now, I don't want to deal in decimals, so what I'm going to do is I'm just going to flip it to make it a little easier. We just said we were allowed to do that. We were allowed to flip. So that means if I do 6 minus pi, suddenly it's a positive number. So my answer is just 6 minus pi. Make things a little bit easier to deal with. So let's take this distance finding stuff and let's kick it up a notch. Let's say I'm on a Cartesian plane and I want to know the distance from P to Q. First thing I do, turn that bad boy into a right triangle, all right? Because you know that a squared plus b squared equals c squared. Only now, we just said that the distance is the absolute value of the difference. So if I do the difference of my x-coordinates and do the absolute value, well, there's my a squared. If I do the difference of my y-coordinates and the absolute value, there's my b squared, and it should equal my distance squared. So from this, so I don't have to draw a triangle every single time, I can use the distance formula. So the distance between 2 points is based on Pythagorean theorem, and the distance is just equal to the square root of the difference of my x-coordinates squared plus the difference of my y-coordinates squared. This is a super useful formula, but do be careful when you use it. Watch your subtraction, watch your negatives, and watch your order of operations, There's all kinds of little places in here to mess up and get tripped up on. You're also probably going to want a calculator because you know not every square root works out to be pretty and perfect and wonderful. So keep a close watch on that. And with this formula in mind, I would like you to use it to go ahead and find the distance between these 2 points. So once again, hit pause to try it out, hit play when you're ready to check your work. So in this case, I'm going to subtract my x-coordinates, which are 1 and 6. I'm going to subtract my y-coordinates, which are 5 and 2, and then I will square them, add it, and do the square root. So 1 minus 6 gives me negative 5. 5 minus 2 gives me 3. I'm going to square both of them. Please don't forget that negative 5 squared is a positive 25. Negative 5 times negative 5 gives me a positive 25. 3 squared is 9. I'm going to add them together, and at this point, I don't know what the square root of 34 is, so I'm going to grab a calculator, and it's about 5.83. So as always, I hope you found this video helpful, and of course, if you have questions or concerns, email me, come see me. I'm around after school on Tuesdays and Thursdays. Thanks for watching, and I'll see you soon. Bye.